Have you ever wondered how our planet is protected from solar wind and cosmic radiation? As we venture into the cosmos, it's crucial to understand the concept of space weather. It's not about rain, snow, or sunshine, but rather a complex interplay of cosmic forces that can have profound effects on our lives and technology. Picture solar wind, a continuous stream of charged particles emitted by the sun, racing toward us at 1,000,000 miles per hour. Or imagine cosmic radiation, high-energy particles from distant galaxies that could damage our DNA. These forces are not just threats for astronauts in space, but can also disrupt our satellites, power grids, and even our health right here on Earth. The universe is a wild, unpredictable, and potentially dangerous place, but fear not, because our planet has a shield, a protective bubble called the magnetosphere. This magnetic armor is our first line of defense against the onslaught of space weather. So, what exactly is this protective bubble, this magnetosphere, you may ask? Well, let's dive right in. A magnetosphere, in the simplest terms, is a region of space where the behavior of charged particles is mainly controlled by a planet's magnetic field. It's like a protective bubble that shields a planet from solar wind and cosmic radiation. But where does this magnetosphere come from? The answer lies within our planet. The Earth's core, made up of molten iron, acts like a gigantic dynamo, creating a magnetic field that extends far into space, forming this protective magnetosphere. Now let's take a closer look at the components of a magnetosphere. First, we have the magnetic field lines. These invisible lines form a pattern similar to the one you'd see if you scattered iron filings around a bar magnet. They help guide charged particles in their movement around the planet. Next up is the bow shock, a boundary where the solar wind slows down abruptly, much like water hitting the bow of a ship and spreading out to the sides. Following the bow shock, we encounter the magnetosheath, a turbulent region where the solar wind slows down and changes direction. The magnetopause is the boundary separating the magnetosphere from the solar wind. It's like the outer wall of our protective bubble. And finally, we come to the magnetotail. This is a long, comet-like tail that stretches away from the sun, formed as the solar wind pushes against the magnetosphere. Each of these components plays a crucial role in maintaining the magnetosphere and, by extension, protecting our planet. They work together, like an intricate cosmic ballet, to deflect and redirect solar wind and cosmic radiation. In essence, magnetospheres are our planet's protective shields against the harsh elements of space. They're the unsung heroes of our existence, tirelessly working in the background to keep us safe, to ensure that life, as we know it, can continue to thrive. Now, how does this magnetosphere protect us from solar wind and cosmic radiation? Well, let's dive into the science of it. Our planet's magnetosphere acts much like a deflector shield you might see in a sci-fi movie. It's an invisible field that envelops our planet, standing guard against the onslaught of the solar wind. This solar wind, a stream of charged particles emitted by the sun, is incredibly powerful and can cause significant damage if it were to reach the surface of our planet. Imagine the solar wind as a torrential downpour and our magnetosphere as an umbrella. Just as the umbrella keeps us dry, the magnetosphere deflects these charged particles, guiding them around the planet and preventing them from reaching the surface. This deflection is crucial, as the solar wind contains not only the energy to disrupt our technologies, but also the potential to strip away our atmosphere. But the magnetosphere isn't just a deflector, it's also a captor. Some of these particles get trapped within the magnetic field and are guided towards the poles. Here, they interact with molecules in our atmosphere, creating spectacular displays of light known as the aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere. These mesmerizing displays are visible reminders of the magnetosphere's ceaseless work. However, it's not just about the light show. These trapped particles also contribute to the Van Allen radiation belts, donut-shaped zones of energetic charged particles. These belts can pose a challenge for satellites and astronauts, but again, our magnetosphere steps in, controlling the intensity and extent of these belts. So in essence, the magnetosphere is our planet's first line of defense against the harshness of space. It's a silent guardian that deflects dangerous solar wind, captures and redirects particles, and even puts on a light show for us. It's an unsung hero of our survival in this vast universe. Without our magnetosphere, life as we know it would be impossible. So the next time you gaze up at the night sky, take a moment to appreciate the invisible shield that makes it all possible. But Earth isn't the only planet with a magnetosphere. Our solar system is dotted with a myriad of celestial bodies, each with their unique characteristics, and some of them, like Jupiter and Mars, have their own magnetospheres. Let's take a journey to Jupiter first. Jupiter, the largest planet in our solar system, also boasts the most massive magnetosphere. It's so large that it extends beyond the orbit of Saturn, making it one of the largest structures in our solar system. Jupiter's magnetosphere is primarily powered by the planet's fast rotation and the presence of a metallic hydrogen layer within the planet, which generates a strong magnetic field. This immense magnetosphere acts like a giant shield, protecting the planet from the harsh solar winds and cosmic radiation. However, the strength of a magnetosphere is not the only determining factor for a planet's ability to sustain life. Let's now travel to our neighbor, Mars. Unlike Jupiter, Mars possesses a very weak magnetosphere. The planet lacks a global magnetic field. Instead, it has scattered pockets of magnetism across its surface. This weak magnetosphere offers little protection against the solar wind, causing the planet's atmosphere to be slowly stripped away over billions of years. This loss of atmosphere has had significant implications for Mars's habitability, making it a harsh and barren world. These differences in magnetospheres across our solar system highlight the importance of this magnetic shield in a planet's ability to sustain life. While Jupiter's strong magnetosphere protects it from solar radiation, its intense radiation belts and lack of a solid surface make it inhospitable for life as we know it. On the other hand, Mars' weak magnetosphere has resulted in a thin atmosphere and a dry, cold surface, conditions not conducive to life. As we can see, magnetospheres play a crucial role in a planet's habitability. So the next time you gaze up at the night sky, remember that the invisible forces surrounding these celestial bodies are as vital as their visible features. So we've learned quite a bit about magnetospheres today. This invisible yet incredibly significant field of magnetic energy around our planet is, in many ways, our silent protector. Starting from the basics, we established that a magnetosphere is a region of space surrounding a planet where the behavior of the cosmic plasma is dominated by the planet's magnetic field rather than by the solar wind. This magnetic field arises from the molten core at the heart of our planet, extending thousands of kilometers into space. We've talked about its two main components, the internal magnetosphere, closest to the Earth, and the external magnetosphere, which is where the solar wind interacts with the Earth's magnetic field. These components work together to form a protective shield around the planet. One of the most crucial roles of the magnetosphere, as we have discussed, is to defend our planet from the solar wind and cosmic radiation. These streams of charged particles from the sun, if not for the magnetosphere, could strip away our atmosphere, erode the ozone layer, and bombard the surface with harmful radiation. It's a constant invisible battle happening above our heads every second of every day. But Earth isn't the only planet in our solar system with a magnetosphere. We've explored how other planets like Jupiter and Saturn have even more powerful magnetospheres, while Venus and Mars, lacking a global magnetic field, are more exposed to the harshness of space. In essence, the magnetosphere is like an invisible guardian, tirelessly working to keep our planet safe from the relentless onslaught of solar wind and cosmic radiation. It's a testament to the incredible natural forces at work, silently shaping our world and making life as we know it possible. Without our magnetosphere, our planet would be exposed to the full force of the solar wind and cosmic radiation, making Earth a much less hospitable place. So, the next time you look up at the sky, take a moment to appreciate our planet's invisible guardian, the magnetosphere.